Back in 2014, the tech industry was operating under a very simple moral compass. Closed systems were the enemy, and open source was the ultimate freedom. If you couldn't see inside a system, you couldn't trust it. We kicked the doors wide open. The target of this rebellion was entirely external. The fight was always against a legacy corporation, a bad manager, or a proprietary software company that locked away its code. The assumption was that if it wasn't your system, it was probably out to get you. We operated on the belief that transparency alone was a shield. If everyone could see the code, participate, and collaborate, the system would naturally govern itself. Bad behavior would be spotted and filtered out by the community. We had completely confused visibility with security. By trusting that a visible system was a safe system, we built digital spaces that left a massive vulnerability hiding in plain sight. Over the next decade, an uncomfortable truth surfaced. A system can be technically perfectly open and still quietly weaponized against the very people operating inside it. In software engineering, an unbounded process operates with zero limits. It rapidly consumes memory until the machine crashes. Human selfishness acts the exact same way. Left unconstrained, it continuously consumes trust and labor, causing the whole structure to collapse. An open space without strict rules is an invitation. It becomes a playground where whoever understands the mechanics best can quietly exploit everyone else. The way to fix this requires moving past political ideals and looking at structural realities. This is a shift toward pragmatic systems thinking. It means prioritizing how a system actually behaves over how we hope it will behave. An idealistic programmer looks at a broken system and asks, why should we accept this? A mature systems architect looks at that exact same system and asks, what specific constraints produced this exact behavior? You don't just tear down an architecture. You map the dependencies, calculate the migration costs, and figure out exactly what happens to the rest of the database when you alter one single component. Protesting reality doesn't write better code. Real engineering requires mapping a system's true boundaries before you even attempt to change them. Let's look at how this plays out at scale. Imagine a telecom platform processing roughly 10 billion data records every single month. A user requests a report, and the database query takes 5 minutes to load. The instinct is to look right at the symptom. You try to add an index or tweak the query, or maybe even replace the database entirely. But a systems thinker looks deeper and asks, why is this architecture allowed to scan this much raw data in the first place? The fix is to build a physical boundary. Using Kafka to buffer incoming traffic forces the chaotic flood of data into a manageable queue. Then, you flatten the storage and pre-calculate heavy metrics during ingestion, doing the mathematical lifting before the user ever asks. By moving the complexity away from the user query and placing it behind a rigid constraint, you mathematically prevent one terrible query, or one bad actor, from bringing down the entire cluster. That is an honest constraint. It is not a corporate policy about best practices, and it is not a suggestion discussed in a morning stand-up. It is a hard, unbreakable digital boundary. These boundaries aren't punishments. They are structural guardrails built on a very specific assumption. Eventually, the actors using the system, whether they are automated scripts or human beings, will act in their own self-interest. Systems do not survive reality because we ask everyone to play nice. They survive because we design physical and digital barriers that hold firm when people inevitably don't. This brings us to a paradox in mature system design. Strict constraints and operational freedom are not opposites. You cannot have one without the other. Smiling through a bad decision isn't collaboration. It's just a way to avoid the cost of saying no. Agreeing to leave a system wide open just to keep the peace and avoid conflict destroys organizations from the inside out. Safety is not the absence of stress. It is the guarantee that the architecture will hold its ground when the components fail, or when the people operating it act in bad faith. Real autonomy is the presence of well-designed, unbreakable boundaries that protect the people working inside the system. Rebellion in the modern tech era looks different. It is no longer about tearing down old companies or blindly protesting against established structures. The most effective form of protest we have left is engineering skepticism. It is the rigorous, disciplined work of building honest constraints. You want to change the system? Fine. But you only earn the right to change it once you deeply understand what it is made of.